Hello guys, we will talk about linked lists in this video. Basically, linked list is a dynamic data structure in which elements form a sequential list. Each node consists of two parts: the node value, which can be integer, character, string, whatever, and the other part is a link to the next node. It's just a pointer that points to the address of the next node, and so on. In linked lists, elements are not stored in memory in a sequential order. They are mapped in memory randomly. Like we see here, the first element is stored at, for example, memory location address number 1. The second element is stored at, for example, address number 9, and so on. They are not in a sequential order. So, there are some properties of linked lists. Like first node is called the head, like this node. And as we said before, elements are randomly stored in memory. Unlike arrays, here the elements are stored randomly in memory, not in a sequential order. There are many types of linked lists. We have here single linked list and doubly linked list and circular linked list. Let's talk about these types and see what is the difference between each type. A single linked list, every node in this list contains only one pointer that points to the next node. In doubly linked lists, we have in each node two pointers. One points to the next node and another one that points to the previous node. And in circular linked lists, the last node, we said before that the last node points to nothing. Here the link is pointing to null. But in circular linked lists, the link part points to the first element again, like we see here. Operations that can be done on linked lists, it's just like arrays. You can insert a new element, delete element, search for a specific element, just traversing the whole list. We will see how to do these operations using C in the next part. So for example, if we wanted to add this new node between this node and this node, we simply make the next node of the new node points to the old node dot next, and then old node dot next points to the new node, as we see here. And in case if we wanted to append a new item to the list, we simply traverse until we reach the last element and make the next node part points to the new node. So let's say we want to delete this node from the list. We simply keep traversing until we reach the node before it, and then make the previous node points to the previous node link points to the node after the node we want to delete. So we will make this node.next point to the node.next of the node we want to delete, like we see here. And to traverse the list, we keep moving, we keep assigning list equal list.next node until list.next node is equal to null. At this moment, we reached the last node of the list. So this is a small example of how to deal with linked lists in C. Here we made a struct of type list node that carry a value which is integer and a pointer to the struct of type list node which is the next node. Here we have three functions: append node and delete node and display list. The append node just return a pointer to the new list after appending the node, and the delete node do the same, just return the pointer to the list after deleting the node. Let's see how we implemented these functions. So the append node takes two parameters: the new value we want to append and the list we want to append the new item to. So firstly we allocate a new node in memory like this and assign its value. Then we check if the list is empty. We just return the new node because it will be the only node in the list. But if the list is not empty, we keep traversing until we reach the last node of this list. Then make the last node.next equal the new node. So to delete a node from the list, we check firstly if the list is not empty. Then we check if the first node is the node we want to delete. We just make the list point to the list.next node, which is the second node. So now the list will start with the second node and remove the first node. In case if the node is not the first node, we keep traversing until we reach the node before the node we want to delete. So if node.next node.value equals the value we are searching for, at this moment this is the node right before the node we want to delete. We simply make this node.next point to the node we want to delete.next. And to display the list, we just keep traversing the list and display the value in the node, in each node. So we keep looping while list is not equal null. We print the value of the current node and then move it to the next node. So let's run this application and see. Let's say we want to add a new node 1 and add a new node 2 and add a new node 3 and display the list 1, 2, 3. Let's say we want to delete 2, so we enter 2, then display. Now 2 is deleted. Let's add a new node 4, for example, and display the list 4 is added.